Hi there. So in this video, we will look at an introduction to fractions. And again, as I've stated before, I will not do every single problem here in this set of notes because the solution key is provided for you online. But rather, I will work through the notes, and if there is repetition in the set of notes where there's extra practice, I will tell you to pause the video and try the next couple on your own and check yourself by the solution key. All right, so with that said, let's jump in. We're looking at here an introduction of fractions, and so the basic definition of a fraction represents the number of equal parts to a whole. So, for example, 5/9, that 5 up top is referred to as the numerator, and the 9 in the bottom is referred to as the denominator. And we can think of this as 5 of 9 equal parts. Proper fractions are where the numerator is less than the denominator, but proper fractions are always between 0 and 1, okay, or 0 and -1. Some examples of proper fractions: 3/4, -4/9, and so on, but you can see in all of these cases, the top number is smaller than the bottom number. Your numerator is smaller than your denominator. Improper fractions, on the other hand, is where your numerator is greater than or equal to your denominator. I like to refer to these fractions as being top-heavy, and improper fractions are always greater than or equal to 1. So like that first one, 4 divided by 4, of course, is 1, but in all of the other cases, all of your numerators are bigger than your denominators, so these are improper fractions. So we'll scoot on down here to example 1, and it says, given this figure, they want us to write a fraction for the shaded and non-shaded portion. So let's do the shaded portion together, and then I'll have you pause the video and you look at the write a fraction for the non-shaded region. So we can see here in this figure that my circle is already divided into 3 equal parts. So that's going to be my total number of parts, and then I want to then, for my numerator, indicate how many pieces are shaded. And in our case here, there is 1 shaded region out of 3 equal parts. So that the fraction that would represent the shaded portion there would be 1/3. Okay, like I said, pause the video and try example write the fraction for the non-shaded portion on your own and check yourself by the solution key. All right, some special fractions down below. Anytime you take a number and divide it by 1, you always get that same number. So you can see in the examples below, 10 divided by 1 is still 10, -8 divided by 1 is still -8. Another special fraction, any number divided by itself is always equal to 1. So you can see here, 12 divided by 12 is equal to 1. -5 divided by -5 is also equal to 1. Any number divided by itself will always equal 1. In number 3, 0 divided by any number is always equal to 0. So you can see that in those two cases, 0 divided by 5 and 0 divided by -8 both give me 0. Because in those cases, it's saying that I have 0 of 5 equal parts. Okay, so that's equal to 0. The difference being now in number 4, any number divided by 0, though, is undefined, because in the example on the left here, it's saying that you have 10 of 0 equal parts. That can't happen. So that would be undefined. So 10 divided by 0 is undefined. -7 divided by 0, also undefined. So 0 in the denominator can't happen. A way that I help myself remember this is that 0 in the numerator is okay, and it equals 0. But if you put 0 in the denominator, NO can't happen, it's not defined. So that's a little device that I use to help myself. So 0 up top, that's okay, and it's equal to 0. But 0 in the denominator, NO can't happen, it's not defined. All right. And then a fact down below, any integer can be written as a fraction by putting that fraction or putting that integer in the numerator with the denominator equal to 1. So in other words, another way of writing 12 is equivalent to saying 12 over 1. -6 is the same as -6 divided by 1. Because you think about it, -6 divided by 1, if you clean that up, that's still -6. That's going to be a useful tip for us, or a useful technique for us in a few moments whenever we have to add and subtract and need a common denominator. All right, so I'm going to flip us on over to the next page. And we're going to talk about factors at the top of the page. And factors are numbers that divide equally into another number. And so the example that I have here is I want us to list the factors of 30. So the way that I help myself generate all of the ways that would multiply, or all the numbers that divide evenly into 30, is that I just try to go down the list of numbers and be methodical about it. So we know 1 goes into any number. So 1 times 30, that's 30, okay? Then the next number after 1 is 2, okay? Well, 2 divides evenly into 30. 2 times 15 will give me 30. Okay, so then I move to the next number on my list, which is 3. 3 goes into 30. 3 times 10. So all of these are now factors of 30. They divide, all of these numbers here now divide evenly into 30. The next number in my list after 3 would be 4. Well, if you did 30 divided by 4, it's not going to be an even number. So 4 is not a factor of 30. So moved on past the 4. Your next number would be 5. 5 goes into 30. 5 times 6. Then the next number after 5 is 6. Once you repeat yourself, then you know you have listed all of the factors. So just start down the normal number line of numbers, 1, 2, 3, 4, 5, 6, and so on. But once you repeat yourself, then you can stop. Okay. Let's do another one here together. In example 2, it wants me to list the factors of 72. So I'm thinking of all the ways that I can multiply to give me 72. Well, I know 1 will go into 72, so because 1 times 72, so those are 2 factors of 72. 72 is even, so I know 2 will go into it, and 72 divided by 2 is 36, so 2 times 36. 72 is also divisible by 3, so 3 will go into 72. 3 times 24. Okay, and if you don't know that off the top of your head, you would just be doing 72 and dividing it by 3 and going through it like that, or using your calculator, whatever your instructor would allow you to use. Okay, then you ask yourself, will 4 go into 72? And it will. 4 times 18. 5's not going to go into 72. 6 will. 6 times 12 is 72. 7 will not go into 72. 8 will. 8 times 9 is 72, and the next number after 8 is 9, and now you've repeated yourself because the factor of 9 would be 9 times 8, and so I'm repeating myself. So these are all of the factors of 72. All of these numbers divide evenly into 72. So you've got 1, 2, 3, 4, 6, 8, and then you can go 9. As far as listing them, it doesn't matter to me how you list them. Okay, I'll let you try pause the video and try example 3 on your own. All right, so down below in example 4, it wants us to reduce these fractions into lowest terms, okay? And by reducing a fraction, you're trying to find then the highest number that divide evenly into the numerator and denominator. So here in example 4, I'd like for us to do letter B and C here together, and then I'll let you pause the video and go back and try letter A. So in letter B, I'm looking for a number that will divide evenly into 10 and 25, and hopefully you would agree here that 5 would go into both of these numbers. So what I'm going to do then is I'm going to divide the top and the bottom by 5. So negative 10 divided by 5 would give me a negative 2. And 25 divided by 5 would give me 5. You'll know you'll be able to stop when the top and the bottom, your numerator and denominator, do not have anything else left in common. And so 2 and 5, the only thing they have left in common is a 1. And so that is reduced terms there for negative 10 over 25. So reducing fractions is going to be very important as you move through in your math class. All right. And then we're looking over at letter C here, it wants us to reduce this to lowest terms. We ask ourselves, do 6 and 13 have anything in common? And in this case, they don't. And so here we would say that this is already simplified. Okay, so I just want to simplify. There we go. I just want to make that notation there that, sometimes whenever you're asked to reduce, it may already be in reduced terms so that you can't go any further, okay? All right, so then let's move on down. Again, I would say pause the video, go back and try letter A, make sure you can reduce that fraction correctly, and check yourself out the solution key. The fact down below says that 2 fractions are equivalent if they represent the same number. So how do we build an equivalent fraction? Okay, so these are the steps for doing that. I'm just going to come down here and show you though instead. Okay, so down in example 5, it wants me to build an equivalent fraction with the given denominator. And this is going to be really important for us here in just a few moments as we add and subtract fractions when we need a common denominator. Okay, I'm going to do letter A and B here with you in the notes and let you pause the video and try letter C. All right, so here's what happens then. You look at your denominator and you look at where it wants you to go to. It wants you to go to 12. So you ask yourself, 4 goes into 12 how many times? And hopefully you agree that's 3 times because 4 times 3 gives me 12. Then I take that 3 and multiply it times the 3 that's already up here. And so 3 times 3 is 9. Okay, you can always check yourself on these. If you reduce this, it should go back to that. So 12 divided by 3 is 4. 9 divided by 3 is 3 because 3 goes into both of those numbers. Okay, but again, just for me to repeat it myself, 4 goes into 12 how many times? 3 times. Take that number and multiply it times up top. So 3 times 3 is 9. Okay. is look at letter B. So here they want us to write 2/5, and then the new denominator here is 55. So we ask ourselves, 5 goes into 55 how many times? Or it's another way of saying 5 times what gives you 55? Hopefully you agree that's an 11. So then I take that 11 and multiply it times the 2 up top. So 2 times 11 is 22. Final answer. Okay, we've built an equivalent fraction because now if I reduce this, if I divided both of those by 11, I'd be right back where I started. Okay. All right, so now let's move on down again. I'll let you try example C there on your own. We're going to look now at adding and subtracting fractions. Whenever you're adding and subtracting fractions, you have to have the same denominators, okay? And so right now, the first few examples here, they all have the same denominator. And so what the rule is then is you keep that denominator, add or subtract up top, and simplify if needed, okay? So let's look at examples 6 and 7 here together. All right, so again, they already have the same common denominator, so I just bring that denominator over. The only thing that gets added or subtracted are your numerators. So here I have 4 plus 1, which gives me 5/10. Hopefully you agree that 5 and 10 still have something in common, so they can be reduced. I could divide them both by, agree with the 5, divide the top and the bottom by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. 1/2, final answer. So you always want to be on the lookout now as you're working with fractions. Whether you add, subtract, multiply, or divide, you're always going to be asked to simplify, okay? Unless you're, in that previous problem where we were just saying specifically build that equivalent fraction, okay? But otherwise, you're always going to be simplifying. All right, so move on over to example 7. Example 7, I am subtracting here. I already have the same common denominator, so I'm going to go ahead and bring that 5 over. Hopefully you remember your rules for with your signs, but anytime you have two negatives side by side, they turn into a positive, so plus plus there. So now I'm really looking at -9 plus 2. You're going to subtract, so 9 take away 2 is 7. Take the sign of your bigger number, that 9's bigger, so it'll be a -7. And then 7 and 5 don't have anything in common, so that is your final answer, a -7/5. Final answer, okay? I'll let you try example 8 on your own. All right, so when we do not have, when we're adding and subtracting and we have different denominators, we're going to have to find our least common denominator and build an equivalent fraction like we already started doing back here in example 5. All right, so let's flip it on over. And let's look at here when we're finding our least common denominator. So here in the example is I want to take 3/8 and subtract 7/10. So in our previous problems, we had the same common denominator, so we could just go straight to it. Whenever the denominators are not the same, we have to get a common denominator. So we look for a number that 8 and 10 will both go into. For some folks, this is very obvious, and you can just go straight to knowing what your common denominator is. For others, here's a method, okay? Always start with your biggest denominator and start listing multiples of that denominator until the other denominator or denominators will go into it. So here, between 8 and 10, 10's the biggest. So I'm going to start listing multiples of 10 until I find a number that 8 will also divide evenly into. So I know 8 won't go into 10, so the next multiple of 10 is 20. 8 won't go into 20 evenly either, because like if you did in your calculator 20 divided by 8, you're going to get a decimal, okay? So the next multiple of 10 is 30. Well, 8 won't go into 30 evenly either. So next multiple of 10 will be 40. So think about it. Okay, well, I know 10 goes into 40, and yep, 8 will go into 40 as well. So that is going to be then my common denominator, okay? So you're always going to start with whatever, between your two denominators, if they're different, you're going to start with the biggest one and count by multiples of it until you find one that all of the denominators will go into, okay? And then we're going to build our equivalent fraction, okay? So I've shown this work down here, but I'm just going to I'm going to stay right up here and show it from top to bottom. So here I've got my 3/8, and I want to subtract 7/10, and I've just found that my common denominator now is going to be 40. I'm going to put a 40 down here, bring out that subtraction sign. All right, we're building equivalent fractions, so I ask myself, 8 goes into 40 how many times? So 8 goes into 40 5 times. Take that 5 and multiply it times the 3 up top, so 5 times 3, 15. 10 goes into 40 4 times. 4 times 7, 28. Now you have the same common denominator. You can bring that denominator over and just subtract up top. 15 minus 28 will give you a negative 13. 13 and 40 don't have anything in common, so that is your final answer. It can't be reduced any further, okay? So that's what I was showing down here below in that building that equivalent fraction. So let's come down and let's look at example 10 and 11 together, okay? Where here it says find each sum or difference, okay? So in example 10, I'm trying to subtract here. I've got different denominators, so I'm going to need to get a common denominator. I'm looking for a number that 5 and 3 will both go into. So again, if you don't know a number that 5 and 3 will both go into, start counting by fives. So I'm just going to make a little list up here for us. So I know, here's the first multiple. Get a different color, get it smaller. So I've got the first multiple of 5 is 5 itself, and 3 won't go into 5. Next multiple of 5 is 10, so I'm just counting by fives, right? So the next one is 10. 3 won't go into 10 evenly. Next multiple of 5 is 15. 3 will go into 15. So remember, I was starting with my highest denominator, and I started counting by multiples of that number until I found one that the other would go into. So that tells me then that my common denominator this time is going to be 15. And now I ask myself, 5 goes into 15 how many times? 3 times. Take that 3 and multiply it times the 4 up top. So 3 times 4 is 12. 3 goes into 15 5 times. 5 times 2 is 10. Subtract. 12 take away 2. Sorry, excuse me. 12 take away 10 will give you 2 over 15. 2 and 15 don't have anything in common. That's your final answer, 2/15. Okay. Let's scoot on over to example 11 here. In example 11, you'll see it looks just a little differently here. You've got -3 plus 11 twelfths. If you remember back on the front page, I had listed for a fact for you that you can always make a whole number, a fraction, by putting a 1 underneath it. Okay, so that's what we want to do here, is we want to put a 1 underneath that -3, so that now that's going to make it easier for us to build our common denominator. So getting our common denominator then, I've got my plus sign here. I'm looking for a number that 1 and 12 will both go into. Well, think about it. 1 goes into any number. So your highest denominator here is 12. So that is going to be my common denominator. It's going to be 12, okay? So now 1 goes into 12 12 times. 12 times -3, -36. The next one, 12 goes into 12 one time. 1 times 11, 11. And I can also tell you this, anytime your denominator doesn't change, the numerator isn't going to change either, okay? So now we just work our way across. -36 plus 11, that's going to give us a -25 over 12. Those two numbers have nothing in common, so I can't reduce any further. Final answer, okay? Again, I'd say stop the video now and go back and try example 9 on your own. All right, so let's move now down into multiplying fractions. When you multiply fractions, you multiply your numerators and denominators straight across and then reduce if possible, okay? So let's look at example 12 here together. So in example 12, you've got your -4/7 times 2/5. I'm going to do just like it said, multiply straight across. So -4 times 2 gives me -8, and on the bottom, 7 times 5, 35. If they had something in common, I would reduce, but 8 and 35 do not. That's my final answer, okay? When you get over to example 13, don't let that 7, throw you off like that. Remember, you can put a 1 underneath it. So you can think of this then as 1/4 times 7 over 1. Again, rule then, just multiply straight across. Those two numbers don't have anything in common. Final answer, okay? All right, so I'll let you try example 14 on your own, all right? And then let's move on over to Actually, let's do example 14 because I want to show example 14 two ways, okay? Because there's actually there's a cross-out method that we'll look at on the next page, okay? So here in method 1, whenever we are multiplying our fractions, and again, when you're multiplying fractions, you're not going to need that common denominator. You only need common denominators when you're adding and subtracting. So multiplying is generally just a lot easier because you can just multiply straight across. Here in example 14, I want to just multiply straight across, and then let's see what happens. So because it does want me to multiply these two fractions together. So I multiply straight across up top, 3 times 8, 24, and on the bottom, 4 times 9, 36. Now I've been saying throughout this video, if you if you have something in common, you need to reduce it. And sure enough, here 24 and 36 still have something in common. They have a number in common. They can both be divided by 12. So 24 divided by 12 gives me 2. 36 divided by 12 gives me 3. So 2/3 would be my final answer there, because I know I can stop because 2 and 3 have nothing in common. Okay, that's my final answer there. If you'll notice, in this particular example, the 4 and the 8 are diagonal from one another, and because they're diagonal from one another, it is illegal for me to cancel them out if they have something in common. Likewise with the 3 and 9, they're diagonal from one another, and 3 and 9 have a factor in common. I could divide both of those by 3's. So anytime something is diagonal or top and bottom from one another, you can always cancel out. You just can't cancel out two tops together or two bottoms together. So let's flip over and look at example 15. Example 15 is the exact same problem that we just got finished doing, but I want us to look at this one with crossing out common factors that they have in common. So here in example 15, like I was saying, the 4 and the 8, they both have a 4 in common. So let's divide both of those by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Okay, so now the 4 and 8 are out of play. You're now dealing with the 1 and 2. Now let's look at 3 and 9. They have something in common. You can divide them both by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now multiply straight across. 1 times 2. And on the bottom, 1 times 3. And there's your final answer. So you can do whichever method you prefer, but I will say this, like when you move on down to like example 17, you start working with much larger numbers. The cross canceling is a valuable technique to be able to work with smaller numbers, okay, and be able to reduce and get to your final answer a little quicker. So like, for example, let's do example 17 here together. Like if I were trying to multiply 45 times 25, I would certainly have to go to my calculator. I wouldn't know that off the top of my head. Now on the bottom, 100 times 18, yeah, I could say that's 1800. And that's a really large number. But let's look at it now in terms of, okay, do I have a numerator and denominator that have something in common? And hopefully you agree here. That 45 and 18, they both have a 9 in common. Let's divide both of those by 9. So 18 divided by 9 would give me 2. 45 divided by 9 would give me 5. All right, that's starting to look better. Now, let's look at 25 and 100. They still have something in common, right? I could divide both of those by 25 itself, right? Because 25 will go into both of those. So 25 divided by 25 is 1. 100 divided by 25 is 4. And now, let's multiply straight across. 5 times 1 is 5. 4 times 2 is 8. And then I know I can stop here. 5 and 8 do not have anything in common, and I am good to go. Okay, final answer. All right. The only thing different in example 16 and 18 is that there's a negative, and all that what I would recommend that you do is look at it from the very beginning. You've got a positive times a negative, so you know your final answer has got to be negative. Just go ahead and write that negative. But you can multiply straight across here and then reduce, or cross cancel in both of those. Okay, so I'll let you try that technique, whichever technique works best for you, and check yourself by the solution key. All right, let's move on down then below. It's possible that you'll sometimes be asked to raise fractions to a particular power. So here in example, let's look at example 20, since that one has the negative with it, and I'll let you go back and do example 19. Here, this negative 2/5 is in parentheses raised to the second power. So what that means is, whatever power is up here, that tells me how many times to write whatever's in parentheses. So here, because that's a power 2, then that's going to tell me to take that negative 2/5 and multiply it times itself 2 times. So negative 2/5 times negative 2/5. If there were 3 up there, then I'd write another times negative 2/5. So that 2 tells me how many times to write negative 2/5. Then from here, you're multiplying. So you are just multiplying straight across. Negative 2 times negative 2. And I will say this, there's no cross canceling that can happen here because 2 and 5 don't have anything in common. So just multiply straight across. Negative 2 times negative 2, that's a positive 4. 5 times 5, 25. Final answer, because 4 and 25 have nothing in common. Okay? All right. Last thing then we'll look at in this particular set of notes is dividing fractions. So the rule for dividing fractions is you copy the first fraction, change it to multiplication, and then you flip the second fraction. You might have heard copy, change, flip, or keep, change, opposite. I've heard those from various folks in the past. Let's look at example 21 and 23 here together. So in example 21, again, I'm going to use that. It tells me to divide here, so the rule is copy the first one, change it to multiplication, and you flip the second one, 5/2. Flipping a fraction is referred to as the reciprocal, okay, if you ever hear that term. All right, so I'm going to ask myself, can I do any cross canceling? So 1 and 2 don't have anything in common. 5 and 6 don't have anything in common. So I'm just going to be able to multiply straight across. 1 times 5, and on the bottom, 6 times 2. 5 and 12 have nothing in common. Final answer, 5/12. All right, we'll scoot on down to example 23. I've got negative 64 over 35 divided by negative 8. Remember, if you've got a whole number, you can make it a fraction by putting it over 1. Still got to copy, change, flip. So negative 64 over 35. Change to multiplication and flip it, so it becomes 1/8. You typically keep that negative up top. I know up here it's, the negatives with the 8, but you just typically put the negative up top. Now from here, I can do some canceling. 8 and 64, they both have an 8 in common. So I'm going to divide them both by 8. 8 divided by 8 is 1. 64 divided by 8 is 8. All right. Now I'm going to look at this, and this would be like a negative 8 now. So negative 8 times negative 1, that would give me a positive 8. And then on the bottom, 35 times 1, 35. So 8 over 35 would be your final answer. Okay. All right. That's the end of that section.